Hi, it's Miss Parrott, and this video is about mole-to-mole conversion using the mole ratio. This is one of the many steps and skills that will help build up to our ability to do stoichiometry problems. Skills you'll need to be able to do before doing this are balancing chemical equations and one-step unit conversion. There will be links down in the description to videos on both of those skills. So start there, then come here. But once you have those down, you'll be able to answer questions like, if you have 4.0 moles of N2, how much NH3 can be produced? Assuming that you have N2, when N2 and H2 come together, they yield NH3. So there are several steps. They're not too hard. Let's get into them. The first thing we're going to do is balance the chemical equation. So if I have N2 here and H2, let's see, I've got two N's and two H's on the reactant side, one N and three H's here. Oh, sorry, my H's are two. So let me do my N's first. If I have two here, I can make this 2 by changing the coefficient. Now I have 2N and 6H. And then what do I need to do to make this 6? Also, I can multiply H2 by 3. And that will give me 6. So now my equation is balanced. It's the coefficients here that will give us the information we need to make the mole ratio. And don't forget, if something like N2 doesn't have a coefficient, the coefficient is 1. You don't have to write it. I'm going to write it here just for the sake of our problem. So once we've balanced the chemical equation, we need to identify the quantities of our known and unknown substances and identify them as A and B. So A is what we know, right? And so we know from the problem that we have 4.0 moles of N2. And we don't know how much NH3 we have. So we don't know how many moles of NH3 we have. All right. The next step is to set up our mole ratio. So we'll use our coefficients. The numbers for this are going to come from our coefficient. So a ratio is just a comparison of two numbers. So in this case, for every 1 mole of nitrogen gas, we can make 2 moles of NH3. So 1, the number that's the coefficient, will go next to the substance that it goes with. So for every 1 mole of NH2, we can make 2 moles of NH3. You could also write this fraction the other way. It means the same thing, right? It's a conversion factor. We're just comparing, it's a ratio between these two numbers. So for every 1 mole of N2, we can make 2 moles of NH3. Later on, we're going to have to decide, which version of this fraction to use. But for now, I just wanted to show you that we can write mole ratio either way. Now, time to convert. Let's set up the unit conversion so that the units and substances cancel, right? Because we're going from moles of one substance to moles of a different substance. This is why, even though it's kind of annoying, we have to write the substance. So we take our known moles of A, which from our problem before was 4.0 moles of N2. We're going to put that over 1 to make it a fraction because we're multiplying fractions. And then our second one, so we want to set it up so the units and substances cancel. If I have moles of N2 on the top in the first fraction, I want moles of N2 in the denominator of my second fraction and moles of my unknown, B, which in our case was NH3 up there. I refer to my mole ratio, my balanced chemical equation, and for every 1 mole of N2, I can make 2 moles of NH3. That's my setup. And now for the easy part. You're going to cancel your units, right? Moles of N2 and moles of N2 cancel. That's how you know you've set it up correctly. If those won't cancel, if those don't match, they won't cancel, you might need to switch. But moles of N2 cancel. Now you're going to multiply across your numerators. 4.0 times 2 equals 8.0 moles of NH3. And then divided by our denominators, multiply across 1. Convert this to a decimal and round however your teacher asks you. In this case, since we had 2 significant digits in the first, like in the problem, 4.0, we want to have 2 significant digits in our final answer. So final answer will be 8.0 moles of NH3. And that's how you do multiple conversion. Keep practicing.